watch this video till then to fall in love with trigonometric integrals. Let's see how to integrate tan to the power 4x. There is no direct formula as such for the integral of tan to the power 4x. In order to integrate tan to the power 4x, we'll have to use the method of u substitution because it's a complicated and composite function. Now, let's say if you want to put tan x is equal to u, okay? If we wanted to put tan x is equal to u, can we do that? We can do that only if the derivative of tan x, which is sec square x present. Is sec square x present over here? It's not. But we can introduce sec square x by doing something in this integral. Let's see how do we do that. So in order to introduce sec square x, what you do is split this into two integrals. Just write it as tan square x times tan square x dx. Okay. And then we can convert one of the tan square x into sec square x. How? Because we know that 1 plus tan square x is sec square x. So we can use this identity and say that tan square x is sec square x minus 1. Okay, so we can write tan square x as sec square x minus 1 using this identity. So this integral is going to become tan square x times sec square x, I'll write this tan square x as sec square x minus 1 with respect to x. So by doing this, I was able to introduce a sec square x, which is derivative of tan x. We can actually multiply that tan square x inside and give that tan square x to both of the terms. So this integral is then going to be looking like tan square x times sec square x. I'll put a bracket. So give that tan square x to sec square x, then minus tan square x times 1 is tan square x with respect to x. Now we can give that integral to both of those terms. So this will look like integral of tan square x sec square x with respect to x minus integral of tan square x with respect to x. We just give that integral to the first term and to the second term. Now, in order to integrate the first integral, notice that the derivative of tan x is sec square x is present over here. So in order to integrate this first integral, we can say that let u be is equal to tan x. We can make that substitution u is equal to tan x because the derivative of tan x, sec square x is present. Now we can differentiate both the sides with respect to x. So we have derivative of u with respect to x is du by dx. Derivative of tan x with respect to x is sec square x. Okay, notice that over here we need to convert this to du. In order to convert this to du, we need sec square x times dx. And from here we can see that sec square x times dx is nothing but du if you multiply by dx. So therefore, from here we can say that du is equal to sec square x times dx. That is our substitution for du. So this can be written as du at this point, and this is nothing but u square because we put tan x is equal to u. So that integral is then going to be looking like we have integral of u square, because tan x is u, this will become u square, and sec square x dx combined will become du. Okay, minus, in order to integrate just tan square x, we can just convert that tan square x in terms of sec square x. We can use the identity. We know tan square x is nothing but sec square x minus 1. Sec square x minus 1 with respect to x. Now we know the integral of u square is nothing but u cube divided by 3 because we are integrating with respect to u, minus, let's put a box bracket and let's give that integral to both of those terms. So we have integral of sec square x dx minus integral of 1 dx. We know u is tan x over here. So this can be written as tan cube x divided by 3 minus, we are almost done with this integration. Bracket, integral of sec square x, we know is nothing but tan x. So this is tan x minus integral of 1 is nothing but x. Let's close the bracket, add the constant of integration c. We can just clean it up a little bit and say we have tan cube x divided by 3 minus tan x. So give that minus to both of those terms. So minus tan x plus this negative and this negative will become positive x plus constant of integration c, and this is your final result.